The second fundamental theorem of calculus is derived from the first fundamental theorem, but this is the theorem that will allow us to compute integrals. So let's begin by define capital F of x to be the antiderivative of little f of x. So what is the meaning of antiderivative? Well, antiderivative is the reverse operation of the derivative. So that means that capital F of x is the function such that when we differentiate it, we get little f of x. Okay. This function is not unique because you can add a constant to this function, and still when you differentiate, you get little f because the derivative of a constant is equal to 0. So the first fundamental theorem of calculus told us that the derivative of the integral from a to x of f of s ds was equal to f of x. So here then we have a function that when we differentiate it, we get little f of x. So this integral then is the antiderivative of little f. So our capital F of x then is this integral from a to x of f of s ds. But as I said, you can add a constant and still have an antiderivative. So to this, we have to add an arbitrary constant. Okay. So this gives us the antiderivative is the integral of f of s ds plus a constant. Now we can determine what that constant is. So we can try x equals a. So if we try x equals a, we have capital F of a is equal to the integral from a to a of f of s ds plus a constant c. But the integral from a to a of any function is 0 because there's no area under the curve if you're always at one single point. So this is 0, and so f of a is equal to c. On the other hand, we can plug in the value b for x, so we get f of b then becomes the integral from a to b of little f of s ds plus c, which is now capital F of a. And that gives us a formula for the definite integral. So we have the integral from a to b of little f of s ds then is equal to the antiderivative of little f evaluated at b minus the antiderivative of little f evaluated at a. And this is the second fundamental theorem of calculus. There's an easier way to remember this because it's a little bit confusing what capital F is. So we can write this in a more transparent way. We can write that as the integral from a to b of the derivative of the function little f, f of s ds. And then we can, instead of having f go little f to capital F, we can have f prime go to little f. So then this is just f of b minus f of a. And that is an easier way to remember the second fundamental theorem of calculus. So let me summarize. We're looking at antiderivatives of our function f of x. Here, initially, we call it a capital F of x. The antiderivative is such that the derivative of the antiderivative is the function, right? So now, if we look at the first fundamental theorem of calculus, we see that the antiderivative is just the integral plus a constant. We can figure out what the constant is, and we get the integral from a to b of little f of s ds equals the antiderivative evaluated at B minus the antiderivative evaluated at A. An easier way to remember this, and maybe one that is more widely used, is that the integral from A to B of the derivative of a function is equal to the function evaluated at the upper limit minus the function evaluated at the lower limit. That's the second fundamental theorem of calculus. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.